How do you attach the roof to a vehicle? A perennial question asked by modelers. The answer usually lies with a choice of soldering, gluing, or screwing, but in this presentation I offer an alternative. I will demonstrate a way I've adopted for forming a roof and attaching it to a vehicle. This is a personal approach which I hope will give you something to think about and perhaps adopt some or all of the ideas. It's open to being adapted and modified, so do feel free to experiment. Breaking a model into parts can be useful, especially when it comes to painting and subsequently fitting glazing, but there may be times when maintenance needs doing. Something might become loose inside, you want to upgrade the chassis, you may want to get into interior lighting of a coach or something. For the neatest job, it's preferable to fix a roof from the inside, but this is not always possible. Or is it? Roofs can be fixed in a number of ways, and my preferred method, wherever possible, is to solder. Where it's not possible, one can use glue, arrange a system of nuts and bolts, use blue tack, or even sticky tape. Here are 5 ways to attach a roof, and a little later I will suggest a 6th. But first, let's look at actually making a roof. This is a method I've developed using ideas from various manufacturers. I make the roof after I've made the body of a vehicle because I need to take some measurements, so a pad and pencil are needed. I make measurements of the length and breadth of the roof itself and the internal dimensions of the vehicle before working out the difference between each of these and dividing that difference by 2. Prepare the roof, smoothing the edges, removing the edging cusps and tabs. Plastic roofs I usually replace with metal because it's stronger and will stand handling better. The reason for dividing the difference in length and breadth by 2 is in order to describe guidelines underneath the roof so that it overlaps the body evenly. These lines are scribed lightly using either a vernier set to the required distance, in this case 2 mm for the overhang at each end, or using a pair of dividers where one point has been set to project a little further. This longer point runs along the edge while the shorter one makes the line. You could also use a woodworker's marking gauge or a ruler and scribe, but I found the vernier or dividers work perfectly well. When the length has been done, reset the scribe to the difference in width and mark the sides. The next step is to roll the roof to shape. We can do this in a couple of ways, by hand or machine. Rolling by hand is done with a round bar, in this case 3/4 inch made of iron. The diameter is not critical, but for comfort, as much as anything, I wouldn't use anything much smaller. Lay the roof on a slightly soft layer. I'm using 2 mm foam from Hobbycraft. Put the rod across it and make sure it is parallel to the long edge of the roof. Press each end of the rod down evenly and firmly with the heels of your hands and roll it gently backwards and forwards. This will curve the roof. With experience, you'll find a suitable underlay to roll on. This method works well for the gentler single arc roofs, but for greater curvature and more complex roofs you may need something a little softer. Experienced modelers sometimes roll the metal on their thighs, but a set of rollers could also be a useful investment. These are George Watt's smaller 6-inch rollers. When you first get them, screw the adjustment screws right down so that the top roller is flat against the other 2 rollers. I've cut and coloured registration marks on the adjustment screws, red on one side of each screw and white on the other, so that I know how they are turned relative to each other. Undo the screws evenly, which is why I cut the registration marks, until you can slot the roof blank in, then turn both screws down about a turn and roll the roof backwards and forwards a couple of times. Turn both screws down a little more, perhaps half or quarter turn, and continue rolling until you have the right curvature. You should be able to remove the roof at any time and reinsert it without undoing the screws. You just need to give the roof a little bit of a push to get it in. Few kits come with formers for roofs. The first I came across was a connoisseur kit for a Y6 tram loco, and the Morgan Design Iron Mink uses a framework because the corners of the van are curved. I'll describe how to make a framework, but if you want just the formers, then ignore the longitudinal spine. To make the formers, use scrap etch cut to the internal width of the vehicle. Clamp it to the end and scribe to shape. This is your template. File the template to shape and check it against the vehicle. If you're making several roofs to the same profile, mark this piece and keep it back for future use. I've also marked the centre, as I'll be making a cut here for the longitudinal spine. Cut more pieces of scrap etch to a similar length and tack solder them together with the template, keeping the bottom edges level. Put them in a vise and file them to the curve of your template. Mark one end so that any inaccuracy in the curvature, however small, is consistent along the length of the roof. If you're going to make a framework, mark the middle and make a vertical saw cut just over half the depth of the former. I found the pen marker I used wears off, especially when the parts are cleaned, so I drilled a hole through one end as a marker instead. This shows why it's important to mark one end and keep all the formers the same way round. With the best will in the world, when doing something by hand, you can very easily err. I've reversed the second piece here in the sandwich. The marked end is now on the left. If the parts are not used the same way round, you'll have difficulty fitting the roof because the sides of the framework will not be in line. In 4mm kits, etched parts are usually made in 12 or 13 thou brass. Here are the approximate widths of cuts for a piercing and razor saw. They'll vary a little depending on the saw blade that you use. At the bottom is a slotting file which cuts only on the edge. Square-edged slotting files at this thickness are not available. This is a luthier's or guitar maker's file and is rounded on the edge but no less useful. They're used to make grooves in the tops of the fingerboard and in the bridge of a guitar to take the strings and come in different thicknesses. I bought mine from Stuart MacDonald in the States, but they can now be found in the UK. Separate the formers and clean them up. You can see the hole I drilled more clearly in this image. For the framework, you need a longitudinal part that is equal to the internal length of your vehicle. Ideally, it'll be about the same depth as the formers. Rounding the corners helps when it comes to fitting the roof. Mark where the formers are going, taking into consideration any obstacles in your vehicle like curved corners, partitions, or stretchers between the sides. Make the vertical saw cuts about half the depth of the piece, then slot the formers in one by one, making sure they're all the same way round. Then solder them together upside down so that the framework is flush along the ridge at the top. Turn it over and you have your completed framework, which you can lay on the inside of your roof, centering it using the guidelines you made earlier. The frame may not match the guidelines exactly, but this doesn't matter. Just make sure any difference is equal on each side. Work on a firm surface, making sure the formers are in good contact with the roof, the curvature of which you can adjust before you begin soldering. Solder the cross pieces first, checking against the guidelines, then work outwards to the edges of the formers. Unless you're going to fix the roof in place permanently, I suggest you do not solder the middle of the longitudinal piece. The reason for this will become clear very soon. You now have your roof made, which is rigid and to the correct curvature for the vehicle, and which should slot inside your vehicle with an even overlap each side and at each end. This is the roof for a Taff Vale Iron Mink from Taff Vale Models. It comes with 2 roof formers, which I used as templates to make 2 more and then make a central spine. Because the van has rounded corners, the end formers had to be set inboard, so it's the spine which is used to get the roof centered longitudinally. Earlier, I said I had another suggestion for attaching the roof, which is magnetism. Gone are the days when there were only relatively weak, soft iron magnets. We now have a wide range of magnets which are very strong relative to their size. I have borrowed these 2 menus from sites on the web. A quick search on Google will show suppliers of a wide range of magnets with varying strengths from a few grams to a pull of industrial strength. 3 of those sites are given here. The strongest magnets, relative to their volume, are made from neodymium, so-called rare earth magnets. It's worth looking at the different sites, as although they sell very similar products, there are some subtle differences. I wanted particular 20mm long magnets for my resistance soldering plate, long enough to get a grip on, but I could only get those from one of those sites. These are some of the magnets I have in stock. The 1x1mm magnets are the weakest and useful for things like joining vacuum or brake pipes, but too weak for attaching roofs. I've used the 2x2mm magnets for roofs, as we'll see later, and I use these in pairs. For most roofs, I've settled on rectangular magnets which are 10mm by 3x2, which have a pull of about 0.8 of a kilogram, 800 grams, or in old money, 28 ounces or 1 3/4 pounds. This might sound a lot, but I only use one magnet and it's not actually touching anything inside the vehicle. Instead of a second magnet, I use ferrous magnetic materials such as a steel sheet or the butt end of an old scalpel blade, here attached to some scrap nickel silver. Cornwall model boats have 1/2 inch by 12 thou stainless steel strip. Some people will cut up old tin cans. The steel I fixed to a stretcher across the middle of the vehicle. The magnetic field is quite strong enough to hold the roof firmly in place. The passenger brake vehicle at the top has a stainless steel stretcher. The LNWR cattle box a nickel silver stretcher with a scalpel blade underneath it. This is the roof for the Taffvale Iron Mink again. Having fixed the framework to the roof, I then cut out the middle portion of the long spine, which is why I suggested not soldering it earlier in the presentation. This then makes space for the magnet. To hold the magnet, I again used scrap etch to make a cradle and tinned the two ends, which I then soldered to the roof. I've marked the corresponding position of the stretcher across the wagon on the underside of the roof so that I can place the magnet in the right place. On this particular roof, for yet another vehicle, I didn't make a framework. I just used the formers at each end to fit against the ends of the vehicle. My system, if it can be called such, as I said at the beginning, is open to variation. On the roof for this Connoisseur Models Y6 Tramloco, the kit comes with 4 formers. I use 2 magnets opposite each other. The chimney and the safety valve in the roof match the castings and the boiler inside the loco. I've used 2x2mm cylindrical magnets, which each have a pull of 15 grams, slightly more than half an ounce. But here there are 2 magnets pulling together, which makes the roof snap nicely into place. I drilled 2mm holes, 2mm deep, and fixed the magnets in with superglue. If you do this, using 2 magnets opposite each other, always check the polarity of the magnets before you fix them in place, or your roof could be spectacularly rejected. This is a Midland and South West Junction Railway 444, originally made by Albion Models but now available from Roxy Mouldings. For the cab roof, again I used 2x2 magnets in pairs. I made the model some 40 years ago and the roof has been attached ever since with blue tack, but this presentation spurred me into making a better job of the attachment. The magnets are held in short 2mm lengths of thin-walled brass tubing, which are soldered to the white metal with 100-degree solder. The magnets are then held inside the tube with superglue. You will notice I've marked where the inside of the cab front and back are and fixed the brass tube along that line to centre the roof. I've also marked which is the front so that the sliding cab vent is the right way round, as are the magnets. Sideways alignment is cast in 2 bars on the underneath of the roof. This suggests another modification that you could use on other roofs. Before I finish, here are a couple of other ways in which I've used magnets. At the beginning, you saw the passenger brake van in 3 parts. I've used magnets to attach the body to the chassis as well as the roof to the top. I used brass tube pins in each corner to locate the body, and marked it so that I always get the body the right way round on the chassis. Inside the body, on 2 stretchers which are lined up with the W-irons, I've put a couple of the 10x1mm self-adhesive epoxy magnets which appeared earlier in the presentation. On the chassis, between the W-irons and above the wheels, I fixed a square of stainless steel, so that when the body is put into place, the magnets are directly above and hold the body onto the chassis. Lastly, I used a 10 by 3 by 2 mm magnet to attach the chassis of the Y6 tram loco to the body. Sometimes it's necessary to remove a chassis, and getting those small screws in and out can be something of a fiddle. At one end, I've used a cheese-headed bolt into the body and made a corresponding slot in the frame spacer on the chassis, which slides underneath the bolt head. At the other end, I set the frame spacer a little lower and put the magnet above it, fixing it on with some double-sided sticky tape. On the underside of the body, I put a piece of scalpel blade in a Mesokits drop-light frame, and with the brass shim made a block to fit between and line up the side frames of the chassis. It's a simple job to pull the front of the chassis up and slide off the bolt, and just as easy to put the chassis back on again. So there we have it, my method of fixing roofs with magnets. By using formers, I ensure the roofs are the right curvature and fit properly. Then the magnets hold the roof firmly in place, and there is no difficulty with soldering or gluing, and I can remove the roof at any time should it be necessary. I recommend marking which way round the roof goes in case there are any inaccuracies in your model. Unlikely scenario, I'm absolutely sure, but you just never know. Anyway, I hope this has given you something to think about, and happy modelling. Goodbye, and thank you for watching.